Hello and welcome to Physics Teacher. Graphing exponential functions in grade 11 math can be fairly tricky, but in this video I'm going to show you how to do it easily and fairly painlessly for any exponential function. Let's get started. Now typically, an exponential function can be written like this in general form, where we have a base of 1/2, but we can have any base. A would be our vertical stretch and compression factor, and if we make it negative, it will be a reflection about the x-axis. Now K is similar. It's also stretch and compression, but it's horizontal, and it can flip if it's negative about the y-axis. Then we have D, which is our horizontal shift, and C, which is our vertical shift. So we have a couple complicated ones here that I'm going to show you how to graph. But in order to graph something complicated, we need to graph something simple first. So what we're doing is we're going to graph the function 1/2 to the power of x. And then we're going to graph all sorts of different transformations and translations of that function. So to do 1/2 to the power of x, we're just going to pick a few easy points. For example, we can figure out what f of 0 is. So if we plug 0 in for x, well, anything to the power of 0 is just 1. So our first point is going to be 0 and 1. Let's mark that on our graph. So right here. What about f of 1? If we plug in 1, well, 1/2 to the power of 1 is just 1/2. So another point would be 1 and 1/2. So it would be here. Now it looks like in this case, because this is a decreasing function, this is just going to get smaller and smaller and smaller and smaller. So instead of choosing f2 and f3, let's go backwards. And let's choose f of -1. Well, if we have 1/2 to the power of -1, well, you just flip that, that's a 2. So another point we could use is -1 and 2, which would be here. Okay, let's do one more. What about -2? Well, that is going to equal 1/2 to the power of -2, which is going to be 4. So our next point is -2 and 4, which is going to be here. So this function, and I'm terrible at drawing curves, but I'll do my best here, looks something like this. Okay, now notice that this x-axis is an asymptote. So this would be y equals 0. That's our asymptote. It's never going to cross that. Okay, so if we're going to write our domain and range, the domain is true for all values of x. So that one's easy. So x, e, r. The range, however, our y values must be greater than 0 for all real values. Okay, now that we've graphed that, we are going to do these complicated ones. So let's see what's happening here. So here we have a horizontal shift and a vertical shift. Now we can rewrite this in this form of f of x, but I'll call it something else. I'll call it g of x, because f of x is this function over here. So g of x is just going to be equal to, so we're going to write this 1/2, but instead of writing x, we're going to write x plus 2. And then we have this -1. So essentially, this is our d value, right there. So this results in a horizontal shift. It moves it left or right. In this case, the d value is -2. So that's moving it left 2 units. So what does that change? That changes our x coordinate. So what we're essentially going to do is look at all of our x coordinates, take whatever value we have, and shift it to the left 2 units. So we're going to subtract 2. So since there's a vertical shift of -1, the y-coordinate is going to go down by 1 unit. So we're going to subtract 1. Now what we're going to do is take coordinates from our original graph and find out what their new coordinates would be for this graph. Let's ignore this one because it's got a fraction in there. Let's just take the three really nice ones. So we've got 0 and 1. How is that going to change for our new graph? Where is that point going to become? So the x-coordinate, which is 0, we're just going to subtract 2. So 0 minus 2 is negative 2. The y-coordinate, which is 1, we're going to subtract 1. So now that's 0. So that point is now going to be here. Okay. Let's look at negative 1 and 2. So our x-coordinate is negative 1. Subtract 2, that's negative 3. And our y-coordinate is 2. Subtract 1, that's 1. So negative 3 and 1. It's right here. And finally, we have negative 2 and 4. And that's going to become, so negative 2 minus 2 is going to give us negative 4. And then 4 minus 1 is 3. So negative 4, 3, 4, and 3. All right, now another thing that's important to note is this vertical shift, which in this example is negative 1. Because it shifts the whole graph down 1, it's also shifting where our asymptote is. So we have a new asymptote. It's not at y equals 0. It's going to be down here at y equals negative 1. So our graph then is going to look something like this as it comes down, approaches the y-axis, but never touches, and continues to go up in this direction. So that's what the graph looks like. Not too bad. Let's add some other shifts and some transformations as well. So looking at this graph, here we've got a negative. That's going to be a reflection about the x-axis. And this is a stretch factor of 2. This is altering the y-coordinate. So what's happening in this case? Well, the y-coordinate needs to be multiplied by negative 2. And then we have a shift just as before, so then we need to subtract 1. What do we have going in here? We've got a negative here, so that's a reflection about the y-axis, so that's changing our x-coordinate. So our x-coordinate, we are going to multiply by negative 1. And then here, it says positive 3, but remember the equation is x minus d, so take the opposite sign there. So that's going to be a negative 3. We're shifting to the left 3 units. Now if you want to see what this equation would look like, let's call this h of x. So we've got negative 2, and then our base 1/2, which is what f of x is. We're going to replace x with all of this, so minus x plus 3, and then we subtract 1. So what is this going to look like? Let's look at our coordinates from the base graph one more time, or the parent graph. So I'm going to do those here. So 0 and 1. What does 0 and 1 become? Well, 0 is x. So we need to multiply that by negative 1. So that's still 0. Subtract 3, we get negative 3. And then we have 1 for y. Multiply that by negative 2, so that's negative 2. Subtract 1, that's negative 3. So 1, 2, 3, 1, 2, right there. Okay, I'm going to do the other ones above so I don't get in the way of my graph. The next one is negative 1 and 2. So what does this one become? So negative 1, that's our x-coordinate, so multiply by negative 1, so that's now positive 1, and subtract 3, so that's negative 2. So then we have our y-coordinate, which is 2, multiply by negative 2, so that's negative 4, subtract 1 is negative 5. So let's write that down, so 2, and 1, 2, 3, 4, over here. Last one, we have negative 2 and 4. So this is going to give us -1, try it for yourself, and -9. Did you get that? Good. So -1 and then 1, 2, 3, 4, 5, 6, 7, 8, all the way down here, if I counted correctly. All right. And then, where is our asymptote? So again, we subtracted 1, so the asymptote has moved down 1 to the y equals -1 asymptote. So our graph is going to come down like this. It's going to keep going forever. And it's going to come up, but not cross the asymptote. Just like that. Or somewhat. That's the best curve I could draw. Alright, so I hope that video helped. If you have any questions, let me know in the comments. And if you're taking grade 12 physics soon, you can download my whole course pack for free in the description. Thanks for watching.